Okay, organic mechanism question for question 11 this time. We've got a major product being requested between the reaction of 2-methyl-buteene and then a non-symmetrical halogen, diatomic halogen. So got to start with the correct material first of all. So we've got 2-methyl-buteene. So we have the buteene molecule, put the double bond in the middle, and then the 2-methyl group coming off carbon number 2. So what we're going to do is add on the ICl molecule to that double bond. So obviously you can see that the double bond is in the middle, which means that the iodine and the chlorine are going to go onto carbons 2 or 3, as I've drawn it there, which immediately discounts answers A or B as being possible products from the opening up of a buteene molecule anyway. The key part to this question, though, is appreciating that the chlorine end is going to be more electronegative than the iodine end of the molecule. And so when the double bond opens in an electrophilic addition style, this double bond is going to attack the iodine in the first instance. And what that's going to do is then open up that molecule. But the important part now is there's actually a multi-step situation here, because what's then going to happen is the double bond is going to open up and we're going to create a carbocation. And as we know, the carbocation now has two possible situations. It can go onto the carbon with the methyl group on, so that would be a tertiary carbocation, or it can go onto the carbon next door on the right hand side carbon. That would be a secondary carbocation, and a carbocation is more stable. It's got more methyl groups around it. So in this case, it would actually form the positive carbon there, which means that the iodine would go onto this carbon. Subsequently, then the chloride minus ion would then add on to the tertiary carbocation centre there, and that's actually going to then correspond to C as being the answer to that one.